So today we're going to be covering Chapter 9, Section 6. Today we're going to be solving right triangles. When we solve right triangles, we're going to be looking for all three missing angles and all three missing sides. We're going to just use all of our prior knowledge. We're going to be using sine, cosine, and tangent. And then remember, when we're looking for a missing angle, we're using the inverse. So this is where we would open up, use either the shift key or the second key. So we would open up either tangent -1, sine -1, and this is read as the inverse of, for example, the tangent, or the inverse of sine. And whenever we use this inverse, we're looking for one of the acute angle measures. So we've already done this. This is just a little key concept here. We're going to be using this if we're looking for any missing angles when we're solving our right triangles. Now, the first example is actually just a word problem. And again, on SATs, PSATs, they love to give you word problems and make you draw your own picture to exemplify the scenario here. So part of the instructions here were to draw a diagram showing a person who is 1.5 meters tall. So let me go ahead and see if I can draw a little picture here. I'm going to draw my stick figure. So here is my person, and he is 1.5 meters tall. And it says this person is standing 20 meters from the base of a building. Here is my building. These are windows, and 20 meters away. And then it says, also show that the person sights the top of the building with an angle of elevation of 58 degrees. Now, normally, your angle of elevation is created from the ground up. But because it's telling us that it's coming from this person's line of sight, then what we're doing here is the angle that's created is here. When we go to get our answer, just like with the kite question in the homework, we have to remember we need to take into consideration this person's height, which is this amount here. So once I find this piece of the building, then I'm going to have to go back and add it to the 1.5 for my final answer. So I could go ahead and move this 20 meters up to this. And now I'm going to label my sides based off of the 58. So based off the 58, the 20 is adjacent, and the X is the opposite. This side over here would have been the hypotenuse. But we don't have a number on it, so we're not using it. So now I need to figure out, in order to find the height of the building, I need to figure out which ratio is going to use adjacent and opposite. And if I write down my SOHCAHTOA, I can see that the trig ratio that uses opposite and adjacent is going to be the tangent. So I'm going to be doing the tangent of 58 is equal to opposite over adjacent. I need to solve for x, so I need to multiply both sides by 20. The 20 cancels, so now I'm left with 20 times the tangent of 58 is equal to x. And then I'm just going to do this on my calculator. It doesn't say what to round to, but we're going to round this to the tenths. I will specify for your test what place to round to. Once you do this on your calculator, you are going to get approximately 32.00669058 rounded to the tenths. I'm just going to make it 32.0. Now remember, that is only for this little piece of the building. So now to get the total height of the building, I'm taking the 32 I just found, plus add in the person's height. So the final height of the building is 33.5 meters tall. So one more word problem here. It says, when the sun's angle of elevation is 38 degrees, a building casts a shadow of 45 meters. So again, let me draw my building here. Here's the sun up above. And it's casting a shadow on the building, or the building's casting a shadow on the ground of 45 meters. It says it's creating an angle of elevation of 38. Remember, the angle of elevation, by definition, is going from the ground upward. So it wants me to find the height of the building. This time it's from the ground, so I don't need to add anything back to it. So I need to find the height of the building. I can call that X. And again, I'm going to label my sides based off of the 38-degree angle. So the 45 is the adjacent side, and the X is my opposite. So again, I need to look at my SOHCAHTOA, and I can see that the ratio that uses opposite and adjacent again, tangent. So I'm going to be doing tangent of 38 is equal to opposite over adjacent. Again, my variable's in the top, so all I have to do is multiply both sides by 45. It cancels from there. And then the tangent of 38 times 45 is going to give me 35.15. Let's see, X is equal to 35.157. It's going to keep on going. Rounded to the tenths place, 35.2 meters is the height of the building. Now we're going to officially see what the name of the lesson was, solving a right triangle. So here it says, to solve a right triangle, this means to find all unknown side lengths and angle measures. So we'll be using sine, cosine, and tangent. We'll also be using the inverse sine, cosine, and tangent. You're going to be given either two side lengths or one side length and one acute angle. So for example, if I have and this is only for right triangles, remember. So if I have a right triangle here, and it's labeled as ABC, and again, lowercase a will be opposite to angle A, lowercase b opposite to angle B, and then lowercase c opposite to angle C. So when I'm done with this, I'll be able to have found angle A, angle B, angle C, and then also lowercase a, lowercase b, lowercase c. So my goal here is to find all of the missing pieces. So let's go ahead and take a look at an example of solving a right triangle. So in this picture, notice it is a right triangle, and they've given me one acute angle and one side length. Now, I know there's only two more slides, this one and one other one. I am going to do another solving a right triangle where they give us two sides, but no acute angles. So I'm going to show you how to do that way as well. All right, so let's go ahead and label the sides in relation to the acute angle that's given to us. So I have the 42-degree angle here. So I can see that the side that is opposite to that is going to be my little a. I'm going to label this as opposite. I'm going to label the side across from the 90 degrees as lowercase c. This is my hypotenuse. And then the side across from the uppercase B will be little b, and this is the adjacent to angle A, which is 42. Now remember, when we solve these, we should be able to find angle A, which they gave us. I don't know angle B. I got to do some work for that one. And then angle C is the 90 degrees. Then I also need to find little a, which is really BC. And then I need to find little b, which is AC. And that was given to me. It's 70 feet. And then I need to find AB, which is my hypotenuse, little c. So when you start these problems, you should automatically be able to fill in 3 of the answers. And then you just have to find the other 3. Now, when they give you one of the acute angles, to find that last angle, it's super easy. All you need to do is, if you understand that the 2 acute angles are complements, just take the 42, subtract it from 90, and that will give you the measure of angle B. So angle B is 48 degrees. And I can fill that in. Now I need to start working on finding the side lengths. So this is where the labels are going to come into play. Now, technically, I could use that newly found angle B if I was confident in my subtraction. But let's say you made a careless mistake. What if you thought 90 minus 42 was 38? And then you try to use that to find little a and little c, you just got those wrong as well. So it's always better to go back to the original given, and I'm going to use the 42. Everybody good on that? All right, so I'm going to go ahead and find little a first. So to find lowercase a, so I'm finding little a, I'm going to look to see what I labeled little a to be. And little a was opposite. And then I'm going to go look for the side that had the number, which was my adjacent. So now I have to figure out which trig ratio is using opposite and adjacent. So if I write down my quick SOHCAHTOA here, I can see that the trig ratio that is going to use opposite and adjacent is going to be tangent. So I'm going to be doing tangent of 42 is equal to opposite, which is A, over adjacent, which is 70. And now I need to solve this. So I can go ahead and multiply both sides by 70. And then 70 times the tangent of 42 is going to give me 63.02, rounded to the tenths, because that's what they set up in the problem. A is equal to 63.0, and this is feet. Now I need to go back and find the hypotenuse. You could also just put 63, either way. Now let's find little c. So now let me go back to my picture, and I can see that little c is the hypotenuse. And again, I'm using the side originally given to me that had a number. So I'm looking for which trig ratio to find little c is going to have adjacent and hypotenuse. And I can see that that's going to be cosine. So I'm going to be doing cosine of 42 is equal to adjacent over hypotenuse. This time my variable's in the denominator. I need to get that variable out of the bottom. So I'm going to multiply both sides by c. And now I have c times the cosine of 42 is equal to 70. And now I'm going to divide both sides by the cosine of 42. Once I do that, 70 divided by the cosine of 42 gives me 94.194. I'm just going to leave the 19, and I need to round it to the tenths place. So 94.2 feet is the length of the hypotenuse. Now, if you think about it, so this side right here is 94.2. The side that was opposite, this one, I found to be 63. It makes sense. Look at your triangle and make sure that the shortest side is across from the shortest angle. The medium size would be across from the medium size angle. And then the biggest side, the hypotenuse, should be the biggest number in your picture. So now that I found all of my pieces, my triangle is complete and I have solved the right triangle. And little c was 94.2, and these are all feet. So when it says to solve the right triangle, we're using all of our prior knowledge to find all of the missing pieces. All right, next slide is a word problem. This time they gave us a picture. And in the problem, they're actually describing what a raked stage is. So it says, suppose your school is building a raked stage. The stage will be 30 feet long from front to back, with a total rise of 2 feet. A rake, which is going to be our angle of elevation, must be 5 degrees or less, is generally the angle preferred for the safety and the comfort of the actors. If it's steeper than that, it's probably not very safe for the actors. So it says, is the rake stage that you are building within the range suggested? So what we need to do is figure out what this angle here is, the raked angle, and make sure that it's less than 5 degrees. So whenever you're looking for an angle measure, remember you're doing the inverse. So because the picture is provided, let me go ahead and label my sides in relation to that angle X. And the stage back over here, this is my opposite. And then the 30, notice it's across from the 90, this is my hypotenuse. So I need to write down my SOHCAHTOA here and figure out which trig ratio uses opposite and hypotenuse. And I can see that I'm going to be using sine. So what we're going to be doing is finding the sine of X, and we're going to be filling in opposite and hypotenuse. So the opposite is 2, the hypotenuse is 30. So when I look for an angle measure, I'm using the inverse here. So inverse sine, 2 over 30. If you are entering this as a division, make sure you put the 2 divided by 30 in parentheses. You will hit enter. And once we do this, we're going to get rounded to the 10th place. Angle X to be 3.8. So because 3.8 is less than 5, this stage is in the desired range. So yes, the stage is in the desired range. So that angle on the stage is in the desired range of less than 5 degrees, or 5 degrees or less. All right, now I'm going to add, so this is the last slide, but I'm actually going to do a problem where you're given 2 side lengths and no acute angle. And then I'm going to show you how to do some of the homework questions, just to clarify the instructions. So I'm going to go ahead and draw a picture. So just add a page to your notes. I'm going to draw a right triangle here. I'm going to label it A, B, C. And the given is going to be this side and this side. Now I'm going to go ahead and label the sides as well. So the side across from angle A is lowercase a. The 14 will be lowercase b. And then the 16 is the hypotenuse. Now, when you're given 2 sides and the instructions are going to say, solve the right triangle or solve the triangle. So when we're done here, I should be able to have found angle A, angle B, angle C. I already know angle C, it's 90. And then lowercase a, lowercase b, lowercase c. I already have b, it's 14. I already have c, it's 16. Now to find a, I'm just going to do Pythagorean theorem because I do not have any of the acute angles. So I'm going to be using a squared plus b squared equals c squared to find the missing side first. So a squared plus 14 squared equals 16 squared. A squared plus 196 equals 256. Subtract 196. A squared equals 60. The instructions might say round to the 10th place. If they say simplest radical form, you would break it down, but we're just going to round to the 10th. So the square root of 60 is going to give me 7.7. So now I've found all three sides and one of the angles. Now what I'm going to do is figure out one of the angles to solve for and label my picture based off of that angle. So what I'm going to do is I'm going to find angle A. So in relation to angle A, little a is opposite, little b is adjacent, and little c is the hypotenuse. So what I'm going to do is the two sides that I have numbers on, this is what I'm using. So I need to figure out TOA, which one uses adjacent and hypotenuse, and that's going to be cosine. So I'm going to be doing cosine of A is adjacent over hypotenuse. Remember, when you're looking for an angle, we're doing inverse here. So 14 over 16. So cosine -1, 14 over 16. And once we do that, we're doing inverse. So either hit your shift key or your second key. And then once you do this, you should be getting angle A is equal to 28.955, and it's going to keep going. I'm going to round to the nearest degree. So I'm going to say angle A equals 29 degrees. So this is nearest degree. If it said near to the 10th place, it would still be the same answer. Now, to find the other acute angle, I can either do another trig ratio, or the faster way would be to take the answer I just got, subtract it from 90, and then angle B equals 61. Now, if you wanted to double check it with another trig ratio, then I'm going to go back to my original picture, and I need to label the sides in relation to B. So now, here's B. This is now opposite, but I'm still using, this is now adjacent here. But I'm going to use just the opposite and the hypotenuse. Again, the original numbers. So if I wanted to use a trig ratio, it would be sine of B is equal to opposite over hypotenuse. I'm still filling in 14 over 16, but I do inverse again. So 14 over 16, and then angle B is going to give me 61.044, rounded to the nearest degree. I get 61 either way. So again, when you're solving this, we're finding all of the angle measures. So A was 29 and B was 61. The three angles should add up to be 180. If they don't, you've done something wrong. Also, make sure your sides make sense. The hypotenuse should be the biggest number. If it's not, you've done something wrong. Now, I just want to clarify two things for the homework, just to make sure you understand the instructions. So I'm going to add another slide here. So at the beginning of the homework, they're going to say, determine which acute angle has the given trigonometric ratio. So that's the main instructions. So then they're going to give you a picture of a triangle. I'm going to do my classic 3, 4, 5 here. And they're going to say which angle, and they're only referring to the two acutes. It's going to be, the answer is either going to be angle A or angle B. So it's going to say which acute angle has the given, so it'll say something like, which one has the sine So the sine of the angle is 3/5. So they want us to know which one would give us the answer 3/5. The way that you'll do this is do both. Do sine of A, do sine of B, and see which one gives you the answer of 3/5. So if I label my picture based off of A, this is opposite, adjacent, hypotenuse. So if I do sine of A, this is going to be opposite over hypotenuse. That's not 3/5. Let's double check sine of B. So now this is opposite. This is now adjacent when I'm talking about B, and still the hypotenuse. So now opposite over hypotenuse, there's the magic ratio. So this answer is angle B. So you just have to do both and then figure out which one gives you the answer. The other thing that is in the homework, they're going to say, use your calculator and find the measure of angle A. And they'll say sine of A equals 0.5. So again, remember, whenever you're looking for an angle measure, we're doing inverse here. So all you have to do is sine -1, put 0.5, and you should be getting 30 degrees. So on those questions where they give you the answer and they want you to find the angle measure, we're doing inverse.